Hi everybody, this is my first tutorial in these coronavirus times, and so I'm getting used to this, so bear with me. But what we're going to do is we're going to go over this first example that we did in class, and I just want to go over it again in case you missed that class, so you can follow along with this on your own time. We're going to do the blink example. And it's in, if you go to Arduino, if you open the IDE and you go to File, Examples, Basics, and Blink, you can find this example. And I'm going to open it up in a second. But before we look at the code, we're going to build the circuit board. And before we look okay. So the first thing that you need is to make sure that you have all your parts out. So the first thing is that we have the board, we have the Arduino Uno board, then we have our breadboard. Remember, this is called the breadboard. And then we have some hookup cables. These are the cables that actually send the signal from one place to another. We have a 220 ohm resistor. And so we talked about on Thursday how to find the correct resistor depending on which ohm you need. There should be a color chart in your kit, or there is a calculator that you can find. And then, but if you're confused, please email me. And then also we have an LED. And then notice that this LED has a long leg and a short leg. Let's see if we can get it to a long leg and a short leg. And the long leg is going to go to the positive power side, and the short leg is going to go to the ground side. So just remember that. Okay, so the first thing I'm going to do is I'm going to plug in the board. And now I can see this green light on, so I know the board is getting power. Okay, that's really important. If your board is not having a green light, then that's the first thing that you should check. So now I'm going to go over to the actual Blink tutorial, because there's a schematic there, which is a visual representation of like a sort of diagram of the circuit. So I'm going to go over there. I'm going to show you what we're working with. So here is the circuit. First of all, this is a little bit of an easier way to look at it. This is from a program called Fritzing, and we might be using this sometimes. But so you can see that the LED is running into the ground, and then the other end is running into a resistor into pin 13. But this is the more standard way of looking at this, and it's good to sort of learn a little bit about how these circuit diagrams are done. But it's pretty easy. So we have pin 13, which if you look on your board, you should be able to see on the right-hand side, there is just a 13. And that's the pin that you're going to send signal into. And so that's the thing you want to recognize first. And then you can go down to the ground, and you can see on your board, it's actually G and D, the same as it is here. So, and then we have signal going from pin 13 to the ground with these two things in between. So the two things that we have in between are the 220 ohm resistor that I just mentioned. This does not have a polarity. This doesn't have an up or down, so it doesn't matter which direction the resistor is facing. And then a signal is going to go into the resistor, and then from the resistor, it's going to go into the LED. And it's important that from this point, from the resistor, the signal goes into the long leg of the LED, And then from the short leg of the LED, our signal is going to go directly to ground. Okay, so that's an explanation of the circuit. So now let's actually build the circuit. So I'm going to bring us back to the phone camera. Okay, we're back. So the first thing that I like to do is to set up our ground and to set up our power. So power usually is it's going to be red. And so what I like to do by setting it up is just to run it from the board to one end of the breadboard so that it's out of the way. Because this is a simple circuit, but when we do much more complicated circuits, we're going to want our ground and our power to sort of be out of the way. And then I couldn't find a longer black cable, so I'm going to use a blue cable for my ground. So I'm going to plug in from, you can't really see it here, but just look at the ground. So I have on the board, it's going to be hard to see, it's upside down, but I have one thing plugged into pin 13, and then one thing plugged into the ground. You can see it there. And then the other end of the cable that's plugged into the ground is going to go into the negative column. And just remember that now every hole on this negative column is also attached to the ground, and every hole on the positive column is also attached to pin 13. They're all connected in the breadboard. That's the point of using these breadboards, is that they make these connections for us. Okay, so now I'm going to go, actually I can pick one way or another. So let's see. I'm just going to go from the positive side. So I'm just going to put in a cable to some random place. So now we have, we've jumped the signal from the positive pin 13 to some random place. And then we know that the other side of this, we want to have some sort of resistor to slow down the signal. Because if we don't have a resistor, it'll be too much power. And so don't force these, don't force the resistor in. It doesn't need to be forced, but you might have to jiggle a little bit. So now we have, so notice that this resistor is going up and down the same direction as the column. So this top leg is not actually connected to the bottom leg, because unlike these columns, these rows on this direction are not connected. So the top leg of the resistor is not connected to the bottom leg. Like underneath, it's being connected by the resistor itself. Okay, so now we're going to take the positive leg of this LED, and we're going to put it right next to, on the same row as this resistor, this 220 ohm resistor. And now the negative one, we're going to put, we're going to plug in this black cable on the same row as the negative leg. And then we're going to put the black cable, the other end of the black cable, into the column, into the column that is connected to the ground. Okay, and now you can see mine is lighting up because I've already flashed the, I've already flashed the signal to it. I've already flashed the program to it. So that's the circuit board. And now I'm going to go to the code and we're going to look over the code. So if you just set up this example, it might not be working yet, but that's okay. This is how you set up the circuit. So. Okay, so over in Arduino, now we can see that, hold on, let me make sure this is working. Okay, now hopefully we can see the Arduino. So I'm using this blink example. So I have it open, but the way that you get to it is File, Examples, Basics, and then Blink. So this is really the simplest thing you can do in Arduino. Just turn an LED on and off. So let's look at this. So like I said on last Thursday, we have a void, or we have a setup and we have a draw. Or actually, we have a setup and we have a loop. And this is the same as the setup and the loop and the draw function in P5. The setup runs once, the loop runs a bunch of times. And then here, this is based on a C type programming language, I think. So that's why this doesn't say function, but these are functions. So in this Arduino language, instead of function, we're going to say void. Okay. Now our first method is called pin mode. And this is going to tell the pin on your Arduino board, your Arduino Uno board, whether to act as an output or an input. So we're going to say, and then just LED built in is a constant that stands for pin 13. So if we just replace it, it will still work. So we're going to set pin 13 to output mode. Later on, we're going to have to set other pins to inputs because we're going to want to get a signal from our board into the computer, like a button or a potentiometer. But now we're only doing outputs. So pin mode 13 output. Now I'm just going to change the other ones just so that we can see and everything is clear. So 13 and 13. Now what's happening here? We're using this function called digital write, which is it is a function that's going to tell the signal that tell the pin to turn on and off. And there's only two choices, on or off. And here, on is referred to as high, and off is referred to as low. So this is a high signal, a high voltage level, as it says right here, high voltage level, or a low voltage level. So a high voltage level is going to be the maximum value of that LED with the resistor that you gave it, and the low is going to be the minimum, which should just be off. Okay, so the other important thing to realize here is that you need a delay function. We're not used to having these. Like in P5, we don't need to have them in there because the loop runs at the rate that we need it to be for animation. But here, if we didn't have something delaying the signal, it would run too quickly, and we wouldn't actually see it turning on and off. It would just be high, low, high, low. It wouldn't break, but it would go so quickly that we would not see the signal. We would not see an actual on and off. But now we can use this delay so that we can see it with our eyes. This 1000 stands for 1000 milliseconds. So basically it's saying turn the LED on, wait 1 second, turn it off, wait another second. Okay, so that's all that we have here. So something interesting that you can do, and will get us towards our Morse code project, is to sort of mess with the pattern here. So I'm just gonna sort of do a few different things. So maybe 500, and then maybe like 700, and then I might just like copy this. make another one, and then make it go to high. And then maybe this one will be long. So we're just making a pattern here. And this is already sort of approximating what Morse code is going to be like. So now I have a longer pattern. And maybe this one will be really, really short. So like 100 milliseconds. Okay. So now I'm going to click verify to make sure there were no mistakes in the code. This is a good thing to do first. Okay. So my Arduino just crashed. I will bring it right back. Okay, finally got it working again. So let me show you the board. I have to trust it. Okay. Now, those changes that I made, I had to go back, but it's basically, I just put 2 more instructions. So a digital write with a delay of 400 milliseconds, then a digital write low with a delay of 600 milliseconds. And you can see now the LED is blinking in a pattern. So for your Morse code assignments, they're going to be very similar to this, except instead of just doing a random number of on and offs like I'm doing, the pattern is going to match Morse code. So it's going to be a certain length of short bursts and then a certain length of long bursts. And you're going to pick whatever length that is. And then, so like some combination of short and long will stand for each letter. And so this is basically going to be how you're going to show your project. It's just going to be a video like this, and then you're going to turn in the code separately. Okay, I hope that was clear enough for everyone. All right, bye.